Let's try to solve this problem. So the height of two buildings is 3.4 times 10 raised to 2 centimeters and 95 feet respectively. If the distance between the two buildings is 473 inches, find the distance between their tops. So let us try to solve this problem. Let us again have the illustration as our given. So as shown, so the height of the two buildings is 3.4 times 10 raised to 2 centimeter. So we have building 1, 3.4 times 10 raised to 2 centimeters, or this is equivalent to 340 centimeters or 3.4 meters. So let's see. Let's say this is building 1, which is 3.4 the height, so let's say this is YA, .4 times 10 or height A, 3.4 times 10 raised to 2 centimeter, and we have 95 feet. 95 feet building. Let's say this is building B, so this is building A, this is building B, this is the height of building B is 95 feet, and the distance between this building is 473 inches. Okay, so find the distance between their tops. Express your answer in meters. So we are being asked to find this distance between their tops. So that's the distance we are being asked of. Now how can we now solve this distance? Let us try to analyze the figure. Let's say this is Z. Okay, let's say this is Z, the distance between their tops. So this will be X. Let's say this is Y. So from the figure we can see that XYZ forms a right triangle, but we are being asked for Z. Now X is equal to this distance, 473 inches. But how about Y? Y is the difference between height of B minus height of building A. So let us try continue solving. So we are required to get Z, the distance between the tops of the building. So Z from Pythagorean theorem, according to Pythagorean theorem, the square of the hypotenuse is equal to the sum of the squares of its sides. So we will have Z squared is equal to X squared plus Y squared, or therefore Z is the square root of X squared plus Y squared. Okay, so but we are being asked to find this, express our answer in meters, so we need first to convert. So X is 473 inches. 473 inches. So how much in meter is 473 inches? 1 meter is approximately 39.37 inches. So for X, let's convert this to meter per 73 inches times 1 meter is 39.37 inches. Cancel. Unit meter will be left behind. So 473 times 1 over 39.37. This is 12.01 meters. So X is 12.01 meters. Okay, we'll make use of that later. How about for Y? For Y, again, Y is HB minus HA, but HB is in feet and HA is in centimeters. So we need to convert those two again into meters. HA is 3.4 times 10 raised to 2 centimeter, or this is equal to 340 centimeters. We all know that 1 meter is equal to 100 centimeters. Therefore, in meters, HA is equal to 3.4 meters, and HB is 95 feet, where 1 meter is approximately 3.28 feet. So 95 feet multiplied by our conversion factor, that 1 meter is 3.28 feet. Cancelled. 95 divided by 3.28, it will be 95 feet times 1 over 3.28. This is 28.96 meters. So HB is 28.96 meters. Now let us go back to our equation, our Pythagorean theorem, because we are asked to find z, where z is the square root of x squared plus y squared. So this is our equation. Now let us try to solve for z. So z is the square root of x squared plus y squared. So it is very important to note that before we solve for a problem, we take note that it should be in the same units. Okay, so that's one of the reasons why we need to be familiar with unit systems and units, because we cannot solve a problem, we cannot solve an equation if the units are different. So just like this one, let us now compute for z. Z is the square root of x squared plus y squared. Oh wait, we now have x, but we don't have yet for y. Y is HB, y is equal to HB minus HA, where HB is 28.96 meters minus 3.4 meters. So 28.96 minus 3.4 meters is equal to 25.56 meters. This is your y. So we now have x and y. We can now solve for z, where z is x squared, which is 12.01 meters squared plus y 25.56 meters squared. So z in meters now, because we are being asked to express our answer according to the problem, express our answer in meters. So solving for z is the square root of 12.01 squared plus 25.56 squared. So the answer is 28.24 meters. This is now our final answer. So z is 28.24 meters. So this distance, according to our figure, and what is being asked in the problem is 28.24 meters.